Hi guys, this is Shiv from Vision Performance. Quick little overview of our new FlexFuel software for the BMW N54 engine. Right now we're in a car. It is running on the new firmware, software, back-end flash, the whole bit. This car currently makes 470 wheel horsepower with stock turbos on the dyno. It's by far the most powerful stock turbo tune that we've ever offered. It's powerful for a few reasons. Number one, it takes advantage of the cooling and octane properties of ethanol. And because we rely on a flex fuel sensor to read ethanol content, we can push these things to a much higher level of aggression safely than without a flex fuel sensor just having to estimate ethanol, which is kind of risky business. Here's a quick overview of the software interface. You can see right here, this value is our current ethanol content. We're at 77.6% ethanol. This is an example of how ethanol content varies from gas station to gas station. In this case, E85 is really E87. From this gas station, we've seen it go as low as E62. So just remember, when you're filling up E85, you're not always getting 85% ethanol. You're getting anywhere between 60 to 85. And that's a pretty big variation, because you can be a lot more aggressive on an 85% ethanol mix than you can with a 60% ethanol mix. In this case, we know it's 77.6%, and we know how aggressive to get. Now, we know not everyone is going to have, at least immediately, a flex fuel sensor installed in the car when running this new update. For that, we've made some provisions, and I'm going to show them to you. Here is our new user-adjustable table. For those running exclusively 85 or mixes of 85, you can ignore map 2. You're really never going to use that. You're basically going to stay on map 3 all the time. That is our flex fuel map. In map 3, you'll see we define the min and max range of ethanol that we want to see. In other words, at the min range, 10%, it runs these values, map 1. Okay? On the max range, when it gets to 70% ethanol, it runs these values. Between this ethanol content and this ethanol content, the tune interpolates tuning data between map 1 here and these methanol compensations. So for example, if we were at, let's say, 40% ethanol, which is kind of in the middle between these two values, instead of running 20% boost or 100% boost, it'll run right in the middle of that, which is what? 60% boost. Okay? Same thing here. Ignition correction, instead of running 0 or running 100, it'll run right in the middle, 50%. Open loop fueling is done a little bit differently, so let's ignore that for now. Same with AFR enleement. You'll see here when you're running 10% ethanol content, there is no AFR enleement, meaning you're going to run the air fuel targets as dictated on the back-end flash. When you go from 10% ethanol or less than 10% ethanol all the way to 70% or more, it enleans by a value of 20. It's kind of an arbitrary unit. A value of 20 is about 1.5 to 2 AFR points. So if the back-end flash is running 11.5 AFR, or 11 to 11.5 AFR, when you're at 70% ethanol, you'll run about 12.5 to 12.7 AFR with that 20 enleement. Similarly, if it's in the middle between 10 and 70, this value will be interpolated to be lower, obviously. So this is the idea behind it. It's a constantly dynamic tune based upon ethanol content. In the baseline file, we establish the min tune, meaning the tune that's run when you have little or no ethanol content, and the max tune, the tune that it kind of morphs to when you run full ethanol content. So you don't have to do anything. You let the Procede do everything by itself. Of course, for those people who don't have a flex fuel sensor, you got to have some discretion when doing this, what I'm going to show you next. But you can define what ethanol content's in your car, and the Procede will read it, your inputs, and assume and behave just like it was coming from a flex fuel sensor. Of course, a caveat here is you need to be careful. You know, if you say you are running 80% ethanol when in reality you're running 60% ethanol, the Procede won't know that without a flex fuel sensor, so it'll run the tune aggression appropriate for 80% ethanol, which will be too aggressive for your ethanol value. So it's almost better to undershoot a little bit to account for variations in gas quality, also to account for the little bit of fuel, the gasoline you always have left in your tank when you fill up with ethanol. So here's where you do that. User-defined content, user-defined ethanol content. When it's equal to 0, set to 0 if equipped with flex fuel sensor, it will disable this input and rely completely on the ethanol, the flex fuel sensor for its ethanol content. But let's say I don't have an ethanol sensor, and I think I'm running 60% ethanol. I can put 60, hit apply. You'll notice now this will start going down to 60. There. So now the tune is going to run 60%. Now the Procede is going to run a tune appropriate for 60% ethanol. And if you want to see something cool, you can actually see it move around here. Let me move this around here. Oh, hold on, I can do this better. There. For example, let's say I have running no ethanol. So whatever no ethanol is, straight gasoline is about 8% ethanol. Hit apply. You'll see that start to drop. You'll see timing start to become more conservative. You'll see fuel correction start changing, and you'll see them move accordingly. There. Likewise here. If I say I'm running 80% ethanol. Oops, sorry. You can see them start to go the other way. And you can see this thing change as well. So once again, it's a very useful feature for those who are very careful with the mixing. Either they test their ethanol chemically with little ethanol test kits, or they be a little bit on the conservative side. So that's basically it. That should give you an idea of how this new system works, and I'm sure we'll have more tutorials about it in the near future as we have more people adopt it. Thank you.